We are separating our consciousness from matter, transforming it into an atomic stream of data. We are making a quantum leap into places even light dares not enter, into ancient hells where physics begins to break. Worlds where molten iron rains from the sky, where horizontal glass storms rage at 7 times the speed of sound, and mountains simply vaporize. Brace yourselves, because what you are about to witness are atmospheric forces so colossal that even the most extreme weather on Earth fades into statistical silence. Our quantum leap carries us 640 light-years away to the Pisces constellation, WASP 76b. This planet is tidally locked. This means one face of the planet gazes at its star for eternity, while the other face is condemned to eternal darkness. When our quantum sensors focus on the day side of this planet, they report that the standard laws of physics collapse. This is an ultra-hot Jupiter. The distance between it and its star is a mere 4.9 million kilometers, or just 16 light seconds. This proximity doesn't just heat the planet's upper atmosphere to 2,400 degrees. It tears matter apart at the atomic level. Under this extreme thermal energy, iron is no longer a metal, but an invisible gas. Physics employs a colossal force to resolve the imbalance between extremes. The massive temperature difference of roughly 1,000 degrees between the day and night sides creates a planetary scale pressure gradient. The result? Supersonic winds reaching speeds of 18,000 kilometers per hour. In accordance with the laws of thermodynamics, iron atoms abandon the unwavering metallic crystal lattice structure of their solid form and mingle into the atmosphere. What you breathe here is not oxygen, but atomized heavy metal vapor. This bright orange mist we observe is actually nothing more than billions of tons of vaporized iron refracting the starlight. The iron gas evaporating on the day side is caught in these massive jet streams and dragged to the dark side in seconds. This line is a universal conveyor belt where matter changes state. The moment gaseous iron crosses this boundary, it is forced into an irreversible phase transition. On the dark side, the temperature drops to 1,500 degrees. For iron atoms, this is a freezing point. Gas molecules rapidly combine, transforming into liquid microdroplets. The sky suddenly darkens, because the clouds are no longer made of water, but of liquid iron particles. Now, prepare your systems. The event you are about to witness is so destructive that it would reduce even the most violent storm on Earth to a statistical silence. Thousands of tons of liquid iron fall freely towards the surface every second, driven by gravity. These drops are as heavy as bullets and hot enough to melt rocks. Here, nature presents iron not as a blessing, but as a molten catastrophe raining down from the sky. Our next destination is a massive world that looks like an innocent water drop in orbit around its star. From a distance, this deep cobalt blue might remind you of oceans, cool waters, and life. But this image is nothing but a cosmic lie. This blueness is born from the very same law of physics that makes us see the sky as blue on Earth, Rayleigh scattering. But here, the thing scattering the light isn't nitrogen molecules. It's molten silicate particles suspended in the atmosphere. In other words, pure glass. On the hellish, star-facing side of the planet, the temperature is so high that rocks boil and vaporize directly. When this scorching rock vapor is hurled to the relatively cooler regions of the planet, it suddenly freezes and crystallizes in mid-air. This planet is not an ocean world. It is a colossal mirror, its atmosphere covered in glass dust, refracting light with a deadly aesthetic. We dive into the depths of the atmosphere, and suddenly that peaceful blue gives way to pure violence. Here, meteorology has turned into a battlefield. The wind speed is 7,200 kilometers per hour. That is exactly 7 times the speed of sound. But the true horror here is not the wind itself, but the payload it carries. These supersonic winds don't blow empty. They carry billions of microscopic, razor-sharp glass crystals within them. Forget that romantic rule of physics where rain falls vertically. Even gravity is helpless against the savage kinetic energy of this wind. The rain falls sideways in a horizontal glass storm. If you were to physically stand inside this storm, the glass shards wouldn't just pierce your body, they would sand you down. In seconds, you would be grated at a molecular level by billions of glass splinters striking 7 times faster than sound. Even your bones would turn to dust and mix with the wind. We leave the glass storms behind. Now, our course is set for a super-Earth, 5 times heavier than our world, with a massive iron core making up the vast majority of its mass. Kepler 2141b. This is no ordinary lava planet. It is so close to its star that an entire year in this hell lasts only 7 hours. Due to tidal locking, one face of the planet is condemned to infinite light, the other to eternal darkness. We descend onto the day side, where temperatures exceed 3,000 degrees. The temperature is so high that when the colossal mountains on the planet's crust encounter this mind-boggling heat, they first melt and collapse into a magma ocean reaching dozens of kilometers deep. However, the star's radiation is so intense that not even molten rock can remain liquid. Just like boiling water evaporating, boiling minerals are stripped down to their atoms and rise into the sky. Here, mountains literally evaporate, turning into a heavy, glowing cloud of fog. Supersonic storms, blowing at over 1.75 kilometers per second, tear these massive rock clouds from the planet's light side and drag them toward the dark side. When these bright, toxic clouds collide with the planet's endless night side, plunging into a freezing darkness of -200 degrees, the laws of physics turn into a cruel joke. Rock vapor, cooling at an unimaginable speed, suddenly solidifies in mid-air. Water does not drip from the clouds here. Here, the sky vomits stone. Sodium and silicon, crystallizing in the air, turn into pebbles, even massive boulders, and begin to rain down. On this pitch-black surface of the planet, the sodium and silicon crystals raining from the sky form massive mounds. But these mounds do not remain motionless. High sodium levels in the atmosphere accumulate on the dark side, forming massive sodium glaciers that resemble Earth's water glaciers but are made entirely of solid metal. Crushed under the planet's merciless gravity and extreme density, these colossal sodium masses and piles of rock slowly slide toward the light side. Much like continental glaciers on Earth carve valleys as they advance. The moment they emerge from the darkness into that 3,000-degree oven, they begin to melt. Solid sodium and stone turn into liquid fire, pouring into the magma ocean as massive glowing rivers. Once merged with the ocean, they await their turn to be vaporized by the star's radiation and rise into the sky again. The final stop on our journey is the globular star cluster Messier 4, located 12,400 light-years away from Earth. Before us is one of the oldest known exoplanets in the universe. This gas giant, with a mass of roughly 2.5 Jupiters, is 12.7 billion years old. This indicates that the planet formed just 1 billion years after the birth of the universe, during the very early stages of the Milky Way. Unlike a standard star system, the cosmic neighborhood it resides in consists of 2 stellar remnants that have already completed their life cycles: a white dwarf and a pulsar. A pulsar is an ultra-dense neutron star formed by the core collapse of a massive star following a supernova explosion. Spinning hundreds of times per second, the pulsar at the center emits high-energy X-rays and gamma rays deep into space. This extreme level of radiation makes the preservation of molecular bonds and the very existence of cellular structures completely impossible. If we were to step out of our quantum form and approach this planet's primordial gas layer, illuminated by violent auroras with a physical body, the relentless X-rays and gamma rays emitted by the pulsar would tear our cellular structure apart in seconds. This savage sea of radiation constantly batters and ionizes the planet's upper atmosphere. So, how did this giant planet survive the devastating supernova explosion created by the pulsar at its center? According to scientists, the answer is simple. It actually never experienced that explosion. According to astrophysical models, this ancient world was originally born in the orbit of an ordinary star. However, as the system drifted through space, it encountered a wandering neutron star. In a gravitational encounter resembling a flawless game of cosmic billiards, the neutron star stole the planet and its host star, trapping them in its own orbit. Over time, the planet's original star also reached the end of its life and turned into a white dwarf. This delicate dance, spanning billions of years, settled the planet into its current stable orbit, where it revolves around both dead stars. It was here before the sun was even a gas cloud, and it has continued to silently witness history in this dark graveyard for over 12 billion years. Now, we leave this chaos behind. As the distance grows, that terrifying heat and pressure fade, giving way to the deep, freezing silence of space. The panorama we have witnessed through our quantum leaps is crystal clear. The universe is not a cradle carefully prepared for life. It is an indifferent, colossal ocean of energy, shaped by the most savage and destructive states of matter. That is why this pale blue dot is more than just a planet. It is a cosmic anomaly. Here, the laws of physics paused, not to rain iron or crush carbon, but to let water flow and chemistry become biology. It is a rare moment of tranquility in the chaos, Yet mathematics whispers we cannot be alone. Among billions of stars, there must be other sanctuaries where life takes root. Now we turn our gaze to those rare havens. Up next, the habitable zone and the search for a second Earth.